Welcome to module number 9 in this Rice 101 module series. My name's Griffiths Atungulu. I'm the director of the Hawkins Rice Processing Program. I'm an associate professor and agricultural engineer. My area of expertise is in grain processing and post-harvest systems engineering, housing in the Department of Food Science with the University of Hawkins System Division of Agriculture. In this module number 9, we are going to delve into rice milling process and systems. We are going to describe the milling process. Then we are going to look at the industrial milling systems in the US. And then we are going to look at some laboratory milling techniques that are very important for us whenever we want to assess rice milling characteristics. To begin with, let's describe the milling process. The milling process typically involves the removal of rice hull and the bran. And the procedure, or the objective of this procedure, is to produce polished rice kernels with minimum breakage. You see in that figure the different components of what a rice kernel has. It has got the bran, it has got a husk, and it also has what we call the white rice. Most of the time, we consume rice in either brown rice form or the white rice form. Now, that rice has to go through a milling process that can separate out the husk and give us those two products that we end up to consume. And that process is accomplished through that rice going through two rolls that are moving in the same direction but at different speed. And because when they move at those different speeds, they cause a shear force that eventually strips off the hull and produces the brown rice. Now, I'll describe briefly what this process involves and some of the byproducts of this milling process. Starting with the rough rice, it goes through the dehuller or the dehusker, as we have seen. That device removes the hull. So the first byproduct is the hull. And we end up with a brown rice. That brown rice still contains the bran on it. And so we need to remove that bran. And to be able to do that, we need a secondary step of milling, and that process will remove the bran and produce milled rice. And typically we have milled rice that consists of whole kernels and broken kernels. And so we need a secondary step that is going to separate the broken kernels and the whole kernels. So briefly speaking, we have the dehulling, we have the milling, and then we have the separation, and we have the byproducts as the hull, the bran, and the brokens. I want to go step by step to look at some of these byproducts of the milling process and some of the areas that they can be utilized in the rice industry. Let's begin with the rice husk, also called the rice hull. This component particularly has got silica and lignin as the components, and because of that, it's not typically available for human consumption and very rarely also used as an animal feed. The common utilizations for this are in rice husk form, or sometimes it is turned in as rice husk, ash, or sometimes it is carbonized to produce energy pellets. And so you could utilize this rice husk in various ways. There are cases where the husk has been utilized as bedding materials for pets, and also cases where, because of its rich content of fiber, some cases it has been utilized to remove some fiber that has been utilized in the pet food industry. Now, the bran component, this is obtained when we go through a milling process to remove the bran. This consists primarily of proteins, fats, ash, and crude fiber. It's a very good source of vitamin B and vitamin E. Now, during the process of bran removal, we also end up producing brewers that have found a lot of application in the beer manufacturing industry. I want to take us through the milling systems that are available in the industry. The first of those is the one-step milling. Now, these milling systems are based on how many times the rice has to go through a milling operation to remove the bran and end up getting whole kernels. So the first case here is a one-step milling. where the husk and the bran removal are done in one pass. In the second case, we have a two-step milling where we have the removal of the husk done separately from the removal of the bran. And the third case here is where we have a myriad of other steps involved besides removing of the husk or removal of the hull. We have many other steps that could involve polishing, destoning, and many other steps. Now, this illustration here is going to take us through a typical industrial milling system, right from the moment we get that paddy all the way until when we mill that rice. And so when that rice comes from the field in paddy form, it contains a lot of impurities. So the first step is to remove those impurities, because those impurities will obviously affect our milling efficiency. And so we remove the impurities using a pre-cleaner. Those pre-cleaned paddy then goes through a rubber roll husker. Again, as I mentioned, the purpose of the husker is to remove the hull or the husk. Now, that rubber roll husker has an aspirator that separates the hull and releases the husk paddy. That the husk paddy goes through a paddy separator. Now, as it goes through the paddy separator, some of the rice that had not been dehusked goes back into the rubber roll husker for a secondary pass of husking, so that at the end of the day, we have completely dehusked or dehulled paddy. That paddy then moves into a destoner that removes any stones that could be in that rice sample before it goes through the actual process of removing the bran. The process of removing the bran can be done in several steps. We have abrasive whiteness, and we also have a friction whiteness. The job of those unit operations is to remove the bran, and the bran is removed progressively to a milling degree that is recommended by an end-use requirement. The industry typically does that until rice obtains about 0.4% surface lipid content. Now, once that bran has been removed, that rice still has a little bit of some chip or cracked rice that we typically refer to as brewers. That is separated using a sifter, and those brewers can be utilized by the brewing industry to manufacture some alcohol or some other products. Then, after the sifting of that rice, now we have whole kernels together with some broken rice kernels after removing the brewers. Those broken rice kernels and the whole kernels go through a mist polisher, and that mist polisher's purpose is to change the surface characteristics of that milled rice and make it have some luster in terms of the physical characteristics, polishes it, makes it look brighter in color before it goes to a length grader. The length grader's job is now to separate the head rice and the broken rice. Now, head rice is typically defined as any rice kernel that has got a length that is 75% longer than a typical milled rice kernel. Anything that has got a length that is shorter than 75% the length of a milled rice kernel is classified as a broken rice kernel. And so in the length grader, that separation is done, and then we can proceed with the blending. And this blending requirement is dictated by the industry and also dictated by the grade of rice that we want to produce. As we know, in grading rice, we grade them based on the amount of brokens that are inside that rice sample. And so blending is done before bagging, and then once it has been blended and bagged, rice is ready for shipment or storage as milled rice kernels. Now, in this figure here, I'm illustrating the typical milling equipment, and this is from one specific milling equipment manufacturer. We have a paddy cleaner, we have a destoner, we have a paddy husker, a paddy separator, thickness grader, then we have series of whitening, polishing equipment, then we have rotary shifters, we also have length graders, and color sorting is also a very important unit operation to help us remove any discolored kernels from the samples before we pack them and bag them ready for shipment. Now, in the laboratory, we typically need to do laboratory milling assessment, and so we have laboratory milling procedures that are simplified compared to what we have in an industrial process. The FGIS, the Federal Grain Inspection Services, has provided different milling procedures that have been standardized for rice milling assessments. And so typically, a specified sample size is procured, and then it is milled, and you utilize a McGill number 3 for this purpose. This is approved by the FGIS, and the milling is done for 30 seconds duration, and then that rice, after it has been milled, of course, we have the broken rice, and we have the milled rice, whole rice kernels. We have to go through a separation process. So in the Federal Grain Inspection Service procedure, we use a series of oscillating cylinders. These are typically inclined, and they help us to separate the broken kernels from the head rice kernels. What you see here is a typical laboratory rice dehuller. This is a Satake model. The sample size for this is about 150 grams. And the way it operates is the sample is fed through the hopper, and then it moves through the equipment that has got 2 sets of rollers that are rotating in the same direction but at different speeds. And because of that, they create a shear force that eventually shears off the hull from the grain, thereby producing brown rice. Again, it's very important to consider the thickness of the grain kernel, because that determines the setting of the spacing between those 2 rollers. Again, the speed of those rollers are all defined by the FGIS standards. Once the brown rice has been produced, we now need to move to removing the bran. And that is accomplished using a McGill number 2 laboratory rice mill. This is the most commonly used rice mill in the US industry for laboratory rice milling assessment. The minimum brown rice sample size for this is about 100 grams. There are other variations of mills that are coming up. We have the Zachariah mill. This Zachariah mill is a slight variation from the McGill number 2 in the sense that it does a compact job that will dehull the rice, will mill the rice all in one pass. With the McGill number 2, we have to get the husk out, we have to get the broken rice kernels and the whole kernels all come together in a mixture, and then we have to do the separation. And so to be able to accomplish and to be able to assess a real head rice yield calculation and be able to tell the amount of sample that came out as a broken kernels and how much came as a head rice kernel, we need to do a separation. And if we are using a McGill number 2, we require a shaker table to accomplish that task. These shaker tables typically come with trays that have different specifications for short grain, for medium grain, and also for long grain. As you can see, those trays have indents, and those indents are designed to carry either short grain or medium grain or long grain. And when that table is being shaken with the grain on it, and it's inclined at the same time, then we have the capability of separating the whole kernels from the broken kernels. And once that has been accomplished, then we are able to calculate our head rice yield from laboratory milling assessments. Now, we have literature here that you can look into to kind of dig a little bit more in terms of some of the things that I've discussed today, understand a little bit more about the milling systems, the laboratory milling assessments, and generally how we do the calculations of the head rice yield and the rest. And so with that, I want to say thank you very much for listening, and I look forward to developing more knowledge in the subsequent modules. Thank you very much.